This video will explain how to use neighborhood operations mean and majority and a local operation combine. Local operations constitute a very important part of data analysis using rasters, and they are cell-by-cell operations. As a result of local operations, we can create a new raster from either a single input raster or multiple rasters. Local operations with multiple rasters are equivalent of vector-based overlay operations. This example will demonstrate how to calculate new values, combine values using multiple rasters. So we are given two rasters, raster A and raster B. If we want to apply this idea to a real-world situation, you might think of raster A as a slope raster and raster B as an aspect raster. In raster A, each cell represents a certain slope value, and in this raster B, each cell represents a certain aspect value. A combine operation will generate a new raster, where each cell will represent a new value as a unique combination of corresponding cells from raster A and B. For example, our first cell in raster A has value 3, and our corresponding cell in raster B has value 3. So 3 and 3, it's not an arithmetic sum of those two values. It is just one unique cell with value 3 is combined with another unique cell with value 3. And we can assign any number to this unique combination as long as it is unique. So I will use 1 to code this combination. The second cell has value 2 and corresponding cell has value 2. I will use a cell with value 3 for this unique combination. So we will assign this value to this cell. Then cell value 1 and 4, and we will use 6 to code this combination. Okay, second cell has value 2 and 3, and we will use 2. 1 and 2. We will use 4 because so far all of these combinations have been unique. 2 and 4, we will use 5. So the next row, 1 and 2. This combination is not unique because we already had 1 and 2 combination and we assigned 4 for this combination. So we will also use 4 for this one. 2 and 4. That's what we already had here, 2 and 4, and we used 5, so we have to use 5 here as well. And finally, another unique combination of 3 and 1, and we will use value 7. So that's how a combine raster can be created using two rasters. Neighborhood operations is the next group of raster operations. A neighborhood operation involves a focal cell and a set of its surrounding cells. The surrounding cells are chosen for their distance or directional relationship to the focal cell. We can use various neighborhood statistics when we work with our rasters. These are, for example, maximum, minimum, range, sum, mean, median, standard deviation, or some tabulation of measures, for example, majority, minority, and variety. Some common neighborhoods include neighborhoods of rectangular shape, circles, analysis, and wedges. So the next slide will illustrate some of these major types. So this is a 3 by 3 cell standard neighborhood. This is circle, annulus, and wage. This example will illustrate how to calculate neighborhood means of the shaded area in the raster A. So each cell in this shaded area can be considered a focal cell of a neighborhood, 3 by 3 neighborhood. So if we will start, for example, with this first cell, with cell value 2, we will consider this cell as a focal cell of the neighborhood that I will outline here. It consists of 9 cells, and it includes cells with values 1, 2, 2, 2, 2, 1, 1, 2, 1. So just imagine that this cell with value 2 is in the center of this neighborhood as it is shown here. To calculate a mean value for this cell, we have to sum all of the cell values of this neighborhood and divide it by the number of cells, which is 9. So here there's an explanation how we arrived at cell value 1.56. We add all of the values 1 plus 2 plus 2 plus 1 plus 2 plus 2 plus 1 plus 2 plus 1 and divide it by 9. It equals to 1.56. The next step is to calculate mean value for the next cell in this shaded area. So this cell with value 2 is a focal cell of a neighborhood of 9 cells that I outlined here. Those are 2, 2, 2, 2, 2, 2, 2, 1, 3. So again, to calculate mean value for this neighborhood, to fill in this cell with value, we have to sum all these 9 cell values and divide it by 9. It is equal to 2. So then this cell is the focal cell of this neighborhood that consists of another set of 9 cells. And the approach is the same. We sum all these 9 cell values and divide it by 9. It is equal to 2.22. This example explains how to calculate majority for the shaded neighborhood. So there is a raster A, and there is our shaded neighborhood, 3 by 3 neighborhood, and we would like to know which cell values are in majority. So we need to calculate it for each of the cells of this neighborhood. So this is our output raster. And the first cell that we will be considering is the focal cell of this 3 by 3 neighborhood. And the cell value that is in majority within this neighborhood is 2. The second cell that will be our focal cell is this cell with value 2. It is part of another 9-cell neighborhood. And in this neighborhood, value 2 is in majority as well. The third cell is a focal cell of another 9-cell neighborhood. And the value 2, as you can see, is in majority as well. So I will use another neighborhood where we have values different than 2. For example, we need to fill in this cell in the neighborhood. So this cell will be our focal cell of the 9-cell neighborhood, and value 3 is now in majority. So the majority value will be 3 in this case.